All right, let's look at this question under mensuration, and it really touches a lot on converting degrees to radians and then like finding arc length and area of sector. So let's just analyze the question first. In the diagram, OPQR is a sector of a circle, okay, and it has center O and radius 12. So let's just see center O, radius 12 cm. And given that this angle POQ is 110 degrees, they want us to find number one, the arc length. So let's just highlight that. What's the arc length? PRQ. And that really is this length. You can see PRQ. Arc length refers to like the length of this arc. And number two, they ask us to find the area of the sector. And so let's just break down the question here. Since it's the first question of this type, I'm going to just go through the main concepts. Number one, it says sector of circle, and so let's just analyze what a sector is. Let me do it up here. So if I have a circle, let me draw a circle. What is a sector? A sector is basically if I cut it like I usually cut a pizza from the center out, from the center out. This is a sector, right? So I can say that if I take this piece out, it will look like this. This will be a sector. Right, I can also take this piece out, and that will also be a sector, because as long as you're cutting from the center out, what you are left with, right, this is also considered the sector. What people usually compare this with is a segment. What is a segment of a circle? If you have a circle and you cut it not from the center, but from the circumference out, then what you get is two segments. This is one segment, right? And this is another segment. So in this case, we are going for sector. So we cut from the center out and we look. Yeah, it does look like it came from a big circle that looks like this, right? And from the center, we cut it out. And what we're left is this. And so I'm just going to erase these portions. All right. So let's just continue analyzing the question now. Now that we see what a sector of a circle is, and we see, okay, radius 12 cm, angle POQ is 110. They want us to find the length of the arc PRQ. And so let's go to the concept of arc length. What is arc length? You can skip this part if you don't need the equation, but otherwise let me show you quickly. Arc length is basically, if let's say you have a sector, as in this case, you want to find this entire length. You don't care about this side and this side. You only care about this side. And let's call this arc length S, and it's spanned by this angle theta. And then we say that the arc, and it's of radius R. Then we can say that the arc length S equals to R theta, where theta is in radians. And so that's simple as that. If theta is not in radians and is in degrees, then just convert it to radians and then apply this formula for arc length. And so in this case, we can see we're going to find arc length. All we have to do is we say that the arc length PRQ is simply R theta, where R is 12 cm. Okay, we run into a problem now because theta is supposed to be in radians, but we have it in degrees here. So let me go through quickly how we convert degrees to radians. And let's see over here. If you want to convert degrees to radians, let me just do it here. And so from degrees to radians, I always just remember this. 180 degrees converts to pi radians, where pi is a number, 3.14159 and so on. And you can find that number in your calculator as well. In this case, we have 110 degrees, so we want eventually on the left hand side to get 110, and we're looking for the number of radians. how do we get from here to here? Well, since I'm converting from 110 degrees, so what I know to do is, let me use ratio. Let me find 1 degree first. Let me divide by 180 to get 1 degree. Of course, on the right hand side, I also divide by 180, and what I get is pi over 180. And then from here to here, I just multiply by 110. And so from here to here, I also multiply by 110. And so what I get is basically, instead of question mark, basically pi over 180 times 110. Right, so I can see that 110 degrees converts to pi over 180 times 110 radians. And so let me just plug that in. So I can say theta is now pi over 180 times 110. Pi over 180 times 110 radians. And so yeah, I just applied this formula for arc length. And since this theta was in degrees, I had to convert it to radians. Right? And then right now, I think it's just important to note that the question states that use pi equals to 22 over 7. So let's just do that. Pi is 22 over 7. And so let's plug it in. 22 over 7 over 180 times 110. And what you get is, and since I used pi as a fraction, what I get is also a fraction. Yep. That's the simplest form. Okay, let's do part B. Now I want to find the area of the sector, and so that calls for another formula. So the first formula we did was length of arc. Now the second formula is area of sector. So let me just explain it over here together with the arc length formula. There's another formula, which is you have this sector once again, and now you want to find the entire area, the whole area of it. And so let's call this area area A, and once again it's spanned by some angle theta and some radius r. And the formula for this is none other than that the area is equal to half times theta times r square, and once again theta is in radians. Okay, so let's apply that. So we say that for part B now, it's part A, we say that the area, this area be A, and it's going to be half times theta times r square. So I'm just going to say this is theta r square, and equals to half times, what is theta? It's in radians. Well, it's the same. I mean, it's the same as part A. It's still 110 degrees, which we converted just now. So let's use that. Theta is nothing but this, pi over 180 times 110 radians. R square now is simply 12. 12 is my radius, and I square it. And I remember once again that pi is 22 over 7 as the question requests. And 12 square, well, I can just say this is 144. Right, I'm just saying 12 square equals to 144. Key everything to a calculator, and what I get is 968 over 7. Well, in this case, I'm leaving it as fraction because I can leave it as a fraction because pi they gave me as a fraction. So everything really is a rational number, and so I'm leaving it as a fraction. If they said pi is like 3.14, then I'm going to give it as a decimal. In this case, they gave me pi as an exact rational number. So what I'm going to do is I'm going to give it as a fraction. I don't want to round off. And there you go. So this question really, it combines, take your time to look through it again if the concepts are new. It combines many different concepts. First one, what is a sector, the idea of a sector, right? They cut the whole pizza from the middle out. And then it applies this formula arc length, and they give you theta in degrees, so you must convert it to radians. And we can see over here, that's what we did, right? Converted radians using this relationship that we know, 180 degrees is always pi radians, and you just use ratio after that to convert. And then the final equation that we know is this, which is area of sector. So let me just write that down, area of sector. So I'm going to zoom out, and you can just take a look at all the concepts at once. And there you go.